Here is a problem on refraction. A scuba diver training in a pool looks at his instructor as shown in the figure. What angle does the ray from the instructor's face make with a perpendicular to the water at the point where the ray enters? The angle between the ray and the water and the perpendicular to the water is 25 degrees. So the picture has a whole bunch of stuff drawn in here. We have this part of it, but that belongs to a different problem in the book. So what we're referring to is this instructor and the diver, and the beams that we're interested in are the incident beam and the refracted beam, and then also this perpendicular to the interface. The interface is between air, and air has an index of refraction of 1. Water has an index of refraction of 1.33 that is not given to us in the problem, but it's something that we can find in a table. So let's see what the problem is telling us. Here are the knowns. We know that the angle between the ray in the water and the perpendicular to the water is 25 degrees. So that would be this angle between the beam to the diver and the interface, the water-air interface, and the perpendicular to the water-air interface. So this angle is 25 degrees. Let's call that angle 2. And then what we're looking for is this angle, the angle of incidence. Call this angle 1. So unknown is theta 1, the angle of incidence. So this is a classic Snell's law problem, which says that n1 sine theta 1 equals n2 sine theta 2. We know everything in this equation. We know the angle, we know the index of refraction for air and water. We're looking for theta 1. So theta 1 then is going to be inverse sine of n2 over n1 sine theta 2. So when we plug in the numbers, we have 1.33 over 1 sine 25. Doing the calculation gives us that theta 1 is 34.2 degrees. So here it is, a fairly straightforward problem on refraction.